Today's lesson is going to be Unit 1.1, and this is what we're going to refer to as Day 1, which is simply just simplifying algebraic expressions and using your order of operations. So remembering what those two things are. So the first thing that we need to take care of are two vocab terms that we're going to be using today. One of them is an algebraic expression, and the other one is a term. Now these kind of go hand in hand with each other, but an algebraic expression is an expression containing operations, numbers, and or variables. And kind of a very simplistic term, a algebraic expression can look like this. 2b plus h. Now those can be different numbers and they can be different variables, or there could be more numbers or anything like that, but the idea is that an algebraic expression has some form of variable in it. Now with a term is a piece of an expression separated by addition and subtraction. If I use the example above or I create something new, let's give the example of 3x squared plus 7h minus 9. Each one of these things that are here are representative of a term. So for example, this 3x squared is a term. The 7h is also a term. And the 9 is a term. Now notice I didn't say negative 9, I just said 9 because it's being separated by addition or subtraction. So the 3x squared, the 7h, and the 9 are all terms of this algebraic expression. Now we do have two more vocab terms that we need to talk about. The first one is a coefficient. Most of you should be familiar with what a coefficient is now, but it's the number being multiplied with a variable, whether it's in front of it, whether it's behind it, whether it's in a fraction. The idea is the coefficient is somewhere that's being multiplied with a variable. So some examples of that: the coefficient in the term 3x, the coefficient is 3. If I give you x squared over 2, your coefficient is actually 1/2. Whether you believe that or not, and we can talk about that in class 2 as well, but your coefficient is 1/2. Or even if it was x3, even though that's not typically how we write that, that is x times 3, and so that 3 would be the coefficient. Now typically coefficients are in front of variables, so anytime that you have a number being multiplied by a variable, always kind of push it to the front, so that's the number and then the variable. Now a new concept might be for you is the degree. It's the combined exponent value of a term of an expression. And so if I was to give you kind of a basic expression or a term, like for example 7x to the second y to the third, the idea is that the exponent value represents a particular number. If there is no exponent, the value is always 1. So the degree of something like this, of this term 7x squared y to the third, is 5, because when you add up the exponents of the variables, not the number, but the exponent of the variables, you get 2 plus 3, which would give you 5. And so that's kind of what degree is, and we're going to work with degree a little bit more too as well. Now this is just kind of for your information here, but you need to remember your order of operations. Now I'm going to add a little bit of extra stuff here to what we kind of know as our PEMDAS model. So the first thing that most of us know is P, which would represent parentheses, but we can supplement to that something that we would refer to other grouping symbols. So brackets would be another grouping symbol that we could typically use, or some other things. The next thing that we know of is exponents, or what we might refer to as roots. And then we have our multiplication and our division here. And if we remember, we can do those from left to right. It doesn't matter what order that they come in, as long as we operate them from left to right. And finally, our addition and our subtraction. So just make sure that you understand your rules of order of operations and how you can manipulate equations or expressions with those. Alright, so going back to some of the things that you learned in Algebra 1, you learned how to simplify expressions. There are basically two ways, this is labeled 1 and 1, But there are basically two ways that we can tell if something is simplified. The first one is that there are no operations to be performed. And basically there's no multiplication, there's no division, addition or subtraction that actually can be done. And then the second thing is all like terms, something that we are very familiar with, are combined. So we need to make sure that we identify, look for like terms, perform any operations that we can. And so our example here is there's no operations that we can technically perform. However, there are like terms that we can combine, being 3k and k. And so the idea here is that we can take 3k minus k and we can simplify that to 2k. Now if we look at 2k by itself, there are no other operations that we can do. There are no other like terms because 2k is the only term that's left. And so here we are done, we are simplified. Okay, so now we have an example in which we are given a longer algebraic expression and we need to simplify it. Now when we're faced with something that has, multiple parts, there's multiple terms here, because remember I kind of told you that this is a term, this is a term, so we have technically 4 terms in this algebraic expression. What we need to identify first is we need to identify like terms. And so in this particular problem, we're looking for the same exponent and variable combination. So 5z squared is a like term with 8z squared, and 10z is a like term with z. Now, one kind of tip that I would give to you when you're trying to simplify these, because you're not going to be sure what is positive, what is negative, always take the operation that's in front of it. Will tell you whether the term is positive or negative. And I can show more examples of this when we're in class. But the idea behind it is we have 5z squared. I'm going to box that one. And we have negative 8z squared. And so if you notice, I took that subtraction symbol to go along with the 8 because that technically is representing for me a negative 8z. And in the same fashion, I will take negative 10z and positive z. Now the reason that we call these terms is we can take them all at one piece, but we need to include the sign that goes with that, and one way to designate sign is with addition or subtraction, meaning it's going to be either positive or negative. So my second thing that I'm going to do is I'm going to combine my like terms. So I'm going to start with the z squareds. So I have 5 and I have negative 8. Remember, when we combine like terms, we only combine the coefficients. We leave the variables alone. We don't change them. And so 5 minus 8 is negative 3z squared. And then negative 10z plus z, that gives us negative 9z. And we look at, and we kind of, when we look at step 3, it's just kind of look at steps 1 and 2. So you kind of go over those. Are there any more like terms? Z squared and z are not like terms, so we're pretty much done here. There's no other addition or subtraction that we can do with any numbers, and so here we are completely simplified. Okay, so we need to simplify and then we need to identify. So what I'm going to ask you to do at some point is I want you to identify the number of terms in an algebraic expression. But we need to make sure that it's simplified before we can start identifying any of those parts. So let's identify our like terms. So we have x to the 8th y. And do we have any similar variable or exponent combinations? And we do not. There is no x to the 8th with an additional y. We go to our next one, xy to the 8th. Well, we have an xy over to the 8th over here, so I'm going to box that with its sign. I'm going to box this with its sign. And then I go to the next one. Do I have any x to the 8th by itself? Sure, there's an x to the 8th over here. With this particular y over here, but because there is a y with it in that particular term, they're not like terms. So now we can go ahead and we can simplify. So we start with the first one, 14 x to the 8th y, negative 14 xy to the 8th, and positive 14 xy to the 8th. Those are going to end up canceling each other out because one is positive, one is negative, and then I'm left with just the plus 14x to the 8th. So now that I have this completely simplified, I can identify how many terms an expression has. Here, we just have one term and we have two terms. And so it's as simple as that. There are two terms to this algebraic expression. The next thing that I need to do is I need to look at the coefficient of each term. And so in this situation, I look at everything in front of every variable, not just one variable, but all of the variables. And so here, my coefficient is 14. So the 14 is a coefficient, and then here 14 is also a coefficient. I won't write it twice, so I'm just going to say that our coefficient in this case is 14. Well, I guess I'll write it again, and 14. And so we've identified coefficients. Now the last thing that we need to do is we need to look at the term with the highest degree. And so the idea is that we need to look at each individual term and determine its degree and then figure out which one has the largest. So we look at, again, the variable exponent worth. And so here we have x to the 8th, so this has an 8. Now y doesn't have an exponent, but remember you learned in algebra that all variables have hidden exponents, and so in this case it's 1. So this degree of this term is 8 plus 1, which gives me 9. And the degree of this term, there are no other variables except for x, and the exponent there is 8, so the degree is 8. Notice that even though they both have x to the 8th, their degrees are not both 8 because we added that additional y. And so the term with the highest degree is simply 14x to the 8th, y to the 1st. And so identifying degrees is probably going to be one of the most difficult things that you're going to do in this particular lesson. Alright, so this is the last example that we are going to attempt today. But what I would like you to do is I would like you to see if you could maybe go ahead and simplify this. It's going to take a few orders of operation, but you've been simplifying expressions like this before. Now, if you haven't already, go ahead and pause it, and then I'm going to go through this relatively quickly to kind of show you what needs to be done. And so the first thing that we need to do is whenever we're simplifying an expression, don't worry about all of this stuff over here just yet, because we'll get to that. First thing that we need to do is we just need to worry about simplifying, and simplifying the right way. And so a lot of the time what we need to start with is we look at our parentheses. So there's really not much that we can do within the parentheses because those are not like terms. And so I need to look outside the parentheses. And remember, whenever you see subtraction out in front of parentheses, you need to distribute that negative or distribute that subtraction to everything that's inside the parentheses. So my next step looks like this: 3xy squared plus 8x minus 2xy squared minus 12. Noticing that I distributed that subtraction. Now I can kind of break this down into my like terms. So I have a like term here, 3xy squared, and I have minus 2xy squared as being my two like terms. Notice again that I included that subtraction with that particular term. So I go ahead and combine those. So 3 minus 2 is 1 xy squared. Notice I only changed the coefficients, not what the variables were. I know it's tempting to combine your variables and say x squared y to the 4th, but don't do that. Leave your variables alone. Plus, well, let's look at 8x. There are no like terms for 8x, so I'm just going to say plus 8x minus 12. Now there are no operations that I can perform because there's no like terms. So in this case, there are 1, 2, 3 terms, and so I have 3 terms. The coefficients on each one of these terms, well, the coefficient in front of this guy right here is 1. The coefficient in front of 8x is 8. And then here's the tricky part. Minus 12 does not have a variable, and so therefore it doesn't have a coefficient. So unless it has a variable, it doesn't have a coefficient. That's just a number. And then now we need to look at the term with the highest degree. Now again, this is where we count up total exponents. So here, let's throw in our hidden ones. So x to the 1st is the same as x, and x to the 1st is the same as x. And so here, this has a degree of 1 plus 2, which in that case is a degree of 3. 8x has a degree of 1 because that variable's exponent only has a combined total of 1. And then 12, that's still a term. We need to still identify the degree, but if it doesn't have a variable, its degree is just 0. And so we have a degree of 3 for the first term, a degree of 1 for the second term, and a degree of 0 for the last term. And so that means our term with the highest degree is 1x squared, or xy squared. And so this is just kind of a shell of what we're going to be doing, and so this isn't the only thing that we're going to be practicing. So if this was a little bit confusing, write down some questions that you had, and then we're going to answer those with a little bit of a warm-up problem and with some practice problems too as well.